What if the most ordinary-looking rocks in space are actually time capsules from the very beginning of everything around us? Asteroids and comets are often called leftovers from the birth of the solar system, but that makes them sound less important than they really are. In fact, they are some of the oldest and most unchanged materials we can study. They formed about 4.6 billion years ago when the sun was still gathering most of the gas and dust. And the rest of that swirling disk began clumping together into planets, moons, and smaller bodies. Here is the basic idea. Early on, the solar system was a giant rotating disk of gas and dust. Tiny particles collided and stuck together, building bigger and bigger objects. In the hotter inner region, only rock and metal could survive, so that is where the rocky planets and many asteroids formed. Farther out, where it was cold enough for water, methane, and ammonia to freeze, icy bodies could survive. That is where comets and many distant small objects came from. But why did they not all become planets? Because the process was not perfectly smooth. Jupiter formed early and became a kind of gravitational sculptor, stirring up material and preventing some regions from ever growing into a full planet. Some pieces got kicked into stable orbits in the asteroid belt. Others were flung into the distant outer solar system, where they became part of the icy reservoirs that later send us comets. This is useful for one big reason. Asteroids and comets are like preserved samples of the original solar system. Unlike Earth, which is constantly reshaped by erosion, plate tectonics, weather, and biology, many asteroids and comets have stayed relatively unchanged. Studying them helps scientists understand what the early solar system was made of, how planets formed, and even where Earth's water and organic molecules may have come from. For example, some comets contain water ice mixed with carbon-rich compounds. That is one reason scientists think impacts from comets and asteroids may have helped deliver water and probiotic chemistry to the early Earth. Not the whole ocean, probably, but enough to make them important in the story of how Earth became habitable. If you want a concrete example, look at missions like OSIRIS-REx and Hayabusa 2. These spacecraft visited asteroids, collected samples, and brought material back to Earth. Why? Because a rock in a lab can reveal things telescopes cannot: exact mineral makeup, isotopes, and organic molecules. That information helps answer questions like, how did the solar system's materials mix? Which building blocks were available before Earth formed? How common are water-rich and carbon-rich ingredients in space? And it is not just academic. Understanding asteroid orbits matters for planetary defense. If we can track what asteroids are made of and how they move, we can better predict impact risk and design deflection strategies if needed. So the next time you hear about an asteroid or comet, do not think of it as just a space rock. Think of it as a leftover fragment of the solar system's origin story, a piece of ancient history still flying through space, carrying clues about how planets were born, how Earth got its ingredients, and maybe how life itself became possible. And that is what makes these small objects so fascinating. They are not leftovers in the useless sense. They are leftovers in the priceless sense. The origins of asteroids and comets, leftovers from the birth of the solar system, is just one small part of asteroids and comets. If you are interested, our full free Asteroids and Comets course is linked in the description.